In the world we live in, with constant improvements in the technology sector, world hunger remains as one of the biggest problems we all face. Did you know 1 out of 8 people experience malnourishment on a daily basis? Therefore, serious actions are needed to be taken because with the recent COVID-19 outbreak, war, and also the increase of food prices due to inflation, primary food sources are already disrupted due to these factors. With that being said, alternative food sources such as alternative protein sources are required for us to be chosen for human consumption. This is because protein is very important to build and also fix our broken tissues and muscles. Out of the many different protein sources, insects are still the most abundant species due to their efficient life cycle and their ability to survive under different weather conditions. And of course, they are rich in protein. However, it is not highly acceptable in the human consumption because food presentation is very important. Let's justify that. All our 5 senses come into play. If you look over here, between options A and B, most of us would actually prefer the B option or the one on the right. But what if I tell you both of these are actually made from insect-based food? There is no doubt if we serve insect-based food with a more presentable and visually appealing manner, more people will accept eating it. That is why we implemented the 3D printing approach for insect-based food formulation. This is to implement the 3D printing technology in the food industry for different customizations in terms of serving, ingredients, dietary requirements, and of course, design customizations. And we can also mimic the fibrous structures of the already available food products so that more people can accept eating insect-based food. And this also promotes satiation, which is the state of being satisfactorily full after human consumption. Let's talk about the engineering side of this project. The pressure-assisted microsyringe design is used for this implication of 3D printing. We have used and utilized this design, which is the rack and pinion design, because of its compact look, a modular system that can allow us to remove the syringe to refill and then attach it back simply. And it is also accurate. However, there is no available research, testing, publications, or even technology regarding this matter in the food printing industry, specifically for insect-based 3D printing. However, we require different engineering approach to this as well, which is firstly optimizing the right sets of 3D printing parameters, such as the right printing speed, printing temperature, extrusion speed, in terms of this design, which is the pressure-assisted microsyringe. Other than that, we also need to optimize the right formulation and ratio for this insect-based food ink or this formulation to be suitable for 3D printing, because we need to achieve the right viscosity for 3D printing. The insect that we have chosen is this, the BSFL or the black soldier fly larvae, because they are abundant, rich in protein of up to 60.69% relative to their mass when they are defatted, and they are already available for animal feed but not for human feed. So with that being said, we can utilize this food formulation or this insect for human consumption with the 3D printing approach. All in all, this project aims to use the 3D printing approach to increase the acceptance of insect-based food, potentially reducing the number of people affected by malnourishment, not just on a daily basis, but with a long-term goal of reducing the number of world hunger. Because insects are rich in protein and they can serve as a very good protein alternative in the case of primary food source or primary protein source disruption. So that is the project. Thank you.